Assalamualaikum warahmatullahi wabarakatuh. Good morning. So today we'll be continuing our topic on thermal physics. So last time we already learned about kinetic particle theory, the states of matter, how matter converts from one state to another. This time we'll be learning about how heat affects matter. Okay, so how heat affects solid, liquid and gas. That is under this topic, thermal expansion. So what is another name for heat energy? So this is thermal energy. Thermal energy and heat energy is similar. Okay, how does heat move? So heat always moves from a hot region to a colder region. So heat always moves from a hot place to a cold place, never from a cold to hot. Heat always moves from hot to cold. Okay, so thermal expansion is basically about heating when something is heated. So if an object is heated, so if it gets hotter, the object expands. When an object is cooled, when it gets colder, no heat, you remove the heat instead, it contracts. So this is how it looks like. So this is the normal object. So when you heat it, this is when you heat, it expands. When you cool it, it contracts. Okay, so from the picture itself, as you can see, from normal to hot, when it expands, the object gets bigger. This is the size of the object after it expands. Contraction from normal to when it's cold, which is this one. As you can see, normal, the object print size was like this. But then after it's cooled down, it gets smaller. Okay, so the volume decreases. Volume decreases, and that is contraction. So expansion is when the volume increase. Contraction is when the volume decrease. Okay, expansion happens when you put heat in. Contraction happens when it gets colder, when you remove heat. So why do solids, liquid and gases expand when hot and contract when cooled? So this is always the law. This is always correct. Solid, liquid and gas always expand when hot, always contract when cooled. So when you cool it down, the particles, okay, as you can see, what happens to particles? The particles lose energy. Oops. The particles lose energy and they move closer to one another. So if you see the distance between this particle and the particle after it moved, after you cool it down, it's closer, it's shorter. So the particles move closer to one another. Because the particles move closer to one another, makin dekat, the volume decreases. Because they get closer, the volume decreases. It becomes smaller. Now let's look when it's hotter. So when you heat up the particles instead, so when you heat up the particles gain energy and they move further away from one another. So again, if you look at the space between one particle to another, it's actually further away, longer compared to when they're in normal mode. So this was normal before it's heated. Okay, so the distance is longer, so the volume expands. So because they are further away from each other, they become bigger, the volume expands. Okay, so this is what happens when it's cooled down. This is what happens when it's heated. So thermal expansion and contraction can happen in solid, liquid and gases, which is these three states of matter. So let's look at some experiments. So this is to prove thermal expansion in solids. Okay, so we have an apparatus, a solid ball, and a solid ring. So before you heat, so this is normal mode, the solid metal ball can pass through the ring. Okay, now we're going to apply heat to the ball. To the solid ball, we apply heat. So when we're applying heat, the ball will expand. Okay, on heating, the metal expands. When the metal expands, the ball becomes bigger. It becomes bigger, so now it cannot pass through the ring. So this shows thermal expansion. So this is the metal ball and ring experiment, the video earlier. So what happens when both ball and ring are at normal temperature? So before you heat it, the ball can pass through the ring. Okay, but after you heat it, when the ball is heated, the ball can no longer pass to the ring because it has expanded. The ball has increased in size due to thermal expansion. Okay, because the particles expand. Okay, so that was for thermal expansion in solid. Now we're looking at thermal expansion in liquid. So the liquid we're looking at is the pink liquid, this one. Okay, so in tap water, this is normal temperature. So this is normal mode. So when you apply heat to it, so you change the tap water into hot water. So now the liquid inside is hot because you put it in hot water. As you can see, the level of the liquid, normally at first it's here. Now it has increased. Okay, it increased. The level increased. So when hot, the liquid expands. So the water level rises. So this increase in liquid is because the liquid inside and the lamane, it expands. It got bigger. Because it got bigger, the level of the liquid increased, makin tinggi. So now let's look at the cold water. So when you put it in cold water, the level of the liquid, it drops, decreases. That's because the cold water made the liquid particles inside, the pink one, contract. Because they contract, the volume decreases. Okay, so because the volume decreases, makin sikit kan to, it lowers. Okay, so this shows thermal expansion in liquid. The experiment to show thermal expansion in gases is also similar. So this time, you're looking at air. Okay, air is gases, yes. So inside here, you have gas particles. You can't see it, of course, but it's there. Okay, and you put a drop of water here. This is just a label. So when you heat it up, you're putting your hand around it. Your hand is warm, so you heat it up. The drop of colored water, it rises. That's because the gas particles in here expands. They move further away. Because the gas particles expands, the drop of colored water is pushed up. Okay, that's why you see the level of the colored water rises. When you cool it down, you put it in ice, the colored water, you put your level, drop. Because the gas inside, okay, we're looking at gas, yes, not the colored water. The gas inside contracts. They get closer. So the volume of the gas decrease. So here, volume of gas decrease. Because the volume of the gas decrease, the colored water drops. Here, because the volume of the gas increase, because it expands, yes, when you expand, the volume increases, the colored water rises because the volume increases. Okay, so as a summary, solid, liquid and gases, when they are heated, they expand. When they are cooled down, they always contract. Okay, again, gases expand more than liquid, and solid expand the least. Okay, so it's easier to heat up gases, and then liquid, and then solids. The volume of a material increases when the material expands. So when you expand something, the volume increases, and when you contract something, the volume decreases. And that's all you learned from today's lesson. Thank you for listening.